Okay, guys, this is the last part of chapter 3 for function. So we're just kind of like going on our qualitative graph kick right here. Okay. So the Environmental Club is learning about oil consumption and energy conservation around the world. Very important topic. Jack says the oil, oh gosh, typo. Oil consumption in the U.S. has dropped a lot. Ashley oh my gosh, Wishart, come on, says that the oil consumption in China is the biggest problem facing the world environment. So then we have two questions here. We have, do you agree or disagree with Jack? And then do you agree or disagree with Ashley? Construct an argument for both of those. So if we take a look here, we have the U.S. is kind of this pink color right here. We have Europe as the green color, China as this kind of darker purpley color, I guess. And then other countries is this kind of blue color. So Jack's statement says oil consumption in the U.S. has dropped a lot. So we've got this is our U.S. consumption right here. And we've got a little drop right here, but I wouldn't say that's dropped a lot. I would disagree, right? U.S. oil consumption has dropped a bit. A little bit, but it's still high. Is still high. So there you go. That's what I'd kind of say about Jack. There's only noises. Do you agree or disagree with Ashley's statement? So we've got oil consumption in China is the biggest problem facing the world environment. Well, look at this, right? In basically this in this like 11-year period, from here it has gone from like, let's say 8,000 barrels to almost 24, like it's almost tripled, right? So boom, right there, right? So agree, right? Oil consumption in China has almost tripled. Right, and it looks like that it's higher than it's even the U.S. has been at its peak right there, which that's crazy. So, a lot of oil being consumed around the world. Okay, a scuba diver starts to dive with a full tank of oxygen. While diving, she breathes at a constant rate. That's important. She checks the gauge after 22 minutes. What does a graph of the function look like? Well, we're going to have right here, we're going to do time in minutes versus oxygen level. Okay, O2 level right there. And so like it starts out at the very beginning of her dive, it's just going to start out high. And again, we don't really have numbers beyond like the 22 minutes, right? And so it's just kind of going to decrease over time as she breathes, right? And it's a constant decrease because she says it breathes at a constant rate, right? Excuse me, I might sneeze. Yeah, it's a constant rate, so it's like it's a line basically, rather than like a goes like this, or I don't know. It's a constant rate rather than kind of like jagging, right? What does a graph of the function look like? Well, oxygen level decreases over time from her scuba tank, right? It's a negative graph. We know that the oxygen level is depleting because we can look at this graph, right? It starts at the green right here, and then after 22 minutes, it's about halfway down. So there you go. So yeah, the weight of the water exerts pressure on a diver at a depth of 10 feet. The water pressure is 19.1 pounds per square inch, and at depth of 14 feet, the water pressure is 20.9 pounds per square inch. Complete the statements, then sketch the qualitative graph of this function. So the depth increases, right? And pressure. Okay, so at a depth of 10 feet, the pressure is, what is it? 19.1, and then at 14 feet. I mean, shoot, we don't really need to put like stuff on this. Again, it's going to be that same thing, right? Nope. As depth increases, pressure increases, right? As you go down in the water. So the input or x variable is increasing. right? Pressure increases as you go deeper, right? So the output or y variable is increasing as well, right? So the deeper you go, the higher the pressure, and that's kind of how the ocean works. Danica sketched the relationship between altitude and time for one of her parasailing flights. Describe the behavior of the function in each interval. We'll just label these as 1, 2, or 3. So this is increasing, this is constant, and this is decreasing. So in interval 1, we know it's increasing. That's her being pulled in the air. Danica being pulled into the air for her parasailing thing, right? Okay, interval 2 is parasailing at a constant. Right, it's constant. Parasailing at a constant altitude, not attitude, golly. Parasailing at a constant altitude, like being dragged by the boat, right? Oops, sorry if you can't see this, golly, my bad. And then 3 is decreasing, running out of room here. This is dropping into the water. Okay. Example 3, sketch the graph of a nonlinear function. Jose is practicing javelin throws. What is the relationship between the height of the javelin and time? What would the graph of the function look like? Well, we can actually just kind of add this on here. We've got time here, and we've got height right here. So this is increasing as it goes up. It's like constant at the very tip top, right? And then it's decreasing right here. So begins right up here, actually, because you don't throw it from the ground, right? You throw it kind of like up in the air, right? So it's increasing here. It reaches a constant point, and then it just travels down right there. So pretty simple. This is going to be 3-6, sketch functions from verbal descriptions. This is going to be on page 39. Okay, again, I'm not going to title it up top because it's already titled. I was wasting so much time doing that. Okay. Okay, 3-6, sketch functions from verbal descriptions on page 39. There you go.